Welcome to day 92 of our school year. All right, let's go ahead and get down our beginning fraction. We have a total of 180 school days, and we are on day 92. Let's go ahead and find the factors of our numerator, which is 92. Two factors we always know are 1 and the number itself. Using the commutative property of multiplication, I can write it down as 92 times 1. Now we're going to use our divisibility rules to check for all our other factors, and we're going to go in order so we don't miss any. So in order after 1 is 2. The rule for 2 is that it ends in an even number. 2 is even, so 2 is a factor. I can't do half of 90 that easily, so I'm going to go down to 80, or 8 tenths. Half of 8 tenths is 4 tenths, and that leaves 12. Half of 12 is 6. Okay, next we're going to try 3. The rule for 3 is that we add the digits together. 9 plus 2 is 11. 11 is not a multiple of 3, so 3 is not a factor. We try 4. The rule for 4, well, you can check also with the second factor with 2. If that's even, then 4 is a factor also. 46 is even, so 4 is a factor. 4 times 23. 23 times 4. Since 2 is doubling, I can actually have 46. Half of 40 is 20, half of 6 is 3. That's another trick for figuring out factors. Next we try 5. The rule for 5 is that it ends in a 0, 5. This ends in a 2, so 5 is not a factor. We try 6. The rule for 6 is that both 2 and 3 are factors. 2 is, but 3 is not, so 6 is not a factor. We try 7. 7 times 10 is 70, 77, 84, 91, 98. 92 is not in that list, so 7 is not a factor. We try 8. Something you can check for 8 is if the second factor with 4 is even, 23 is odd, so 8 is not a factor. The rule for 9 is the same as 3. We add the digits together, we get 11. 11 is not a multiple of 9, so 9 is not a factor. We try 10. The rule for 10 is that it ends in a 0. It ends in a 2, so 10 is not a factor. We try 11. 11 times 8 is 88, then 99. 92 is not in that list, so 11 is not a factor. I'm going to see if 23 may be prime, because if we've gone in order and our second factor is prime, then we are done. Yes, 23 is prime, so we have found all our factors, because 23 won't break down into any more multiples. So let's list our factors from least to greatest. 1, 2, 4, 23, 46, 92. We have 6 factors. That is more than 2 factors, so it is composite. Now we need to find our greatest common factor. Since our unshaded area only has 88, I can't make a group of 92. The shaded is 92, but 88, I can't make another group of 92. So I don't even need to try 92. Let's go on to the next greatest factor, which is 46. Remember, your groups do not have to look like mine, but you do need to keep your shaded separated from your unshaded, and you do have to have 46 in each group. Okay, 4 plus 40 plus 2 . 8 plus 30 is 38. Plus 8 more is 46. And then I have 42 left over, so I can't make a group of 46, so that means that 46 is not our greatest common factor. Let's trade 23. Again, your groups do not have to look like mine. 18 plus 5 is 23. 5 plus 18 is 23. Let's see. I did something wrong here. Let's see. Oh, that's 17. That's why. And then always be thinking about what you're doing. The steps have to make sense. If they don't make sense, stop and reevaluate. See where the problem may be. Okay, here I have 18 plus 5. 5 plus 18. 22 plus 1. I have 19 left over, so 23 does not work because I have a remainder. Okay, so let's go ahead and make groups of 4. I'm going to use perfect squares to help me out here. I like making perfect squares. 4 is a perfect square. That means that both sides are the same length to make it a square. 2 times 2 is 4. But you do need to keep your shaded separated from your unshaded. So I'm not making cubes here. I'm going to do 1 times 4. I'm going to use that array to keep my shaded separated from my unshaded. You just have to make sure you have 4 in each group. And there we go. I have no remainder, so that means 4 is our greatest common factor. Let's go ahead and count up our total amounts of groups of 4. The way I made mine, I have 5 groups of 4 in each row, so I can count by 5s. 5, 10, 15, 20, 21, 22, 23, 24, 25, 30, 35, 40, 45. Now I'm going to count how many are shaded in. 5, 10, 15, 20, 21, 22, 23. Okay, so now that I've done my division with my model, I'm going to go ahead and use my algorithm to check, because if I can get the same answer doing it 2 different ways, I can be pretty sure that I am correct. So I am dividing both by my greatest common factor of 4. Four quarters is $1 or 100 cents. Numbers the same, zeros a game, more on top, no need to stop. Numbers the same, zeros a game. 20 times 4, well, the placeholder moves it over a place. 2 times 4 is 8. Numbers the same, zeros a game. Add these partial quotients together. 5 plus 0 is 5. 20 plus 20 is 40. 20 times 4 is 80. More on top, no need to stop. More on top, no need to stop. 3 times 4 is 12. Numbers the same, zeros a game. Add our partial quotients together. 20 plus 3 is 23. Now we still need to check. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder is 0 for both, and the identity property of addition says when you add 0 it stays the same, we don't need to take the time to add 0. 4 groups of 5 is 20. So I regroup the 2 tens in the tens place. 4 groups of 4 tens is 16 tens, plus the 2 more tens is 18 tens. 4 groups of 3 is 12. 4 groups of 2 tens is 8 tens, plus 1 more is 9 tens. So 92, that matches our dividend up here. So that checks. 180, that matches our dividend up here. So that checks. That means our numerator is definitely 23 and our denominator is definitely 45. All right, let's go ahead and fill in our data collection page. Okay, trimester 2, week 7. Today is 1/16/2020. And our fraction for today is 23/45. Okay, we did groups of 4, so let's go ahead and get out our number line and look at our groups of 4. The last one we have is 22/45, and then 23/45. That is our simplest form or equivalent fraction in lowest terms, but we do have an equivalent fraction in the 2's. 2 is a common factor, but 4 was our greatest common factor. All right, go ahead and put your number line away, erase your worksheet, and thank you for joining me.